Welcome class to this video entitled From a Quadratic Relation to a Parabola. In this video I'm going to go over with you how to complete this handout, which you should see in the attachment for this assignment. I'm going to be focusing on the difference between linear and quadratic relations. We will then look at in more depth the equation for a quadratic relation, and then we will determine what can we know about a parabola based on its corresponding equation. All right, so to start us off, we're just going to reflect on something that we should have learned in grade 9. In grade 9, we learned about linear relations, and when we had a linear relation and we graphed it, we created a line. Now we're going to be doing quadratic relations, and when we graph that, we get a parabola. And it's important to note that the parabola refers to the shape of the graph, while quadratic refers to the type of relation that gives you that shape. All right. Now you can recall from last year as well. Linear relations often look like y equals 2x plus 3, right? Where 2 is the slope and 3 is the y-intercept. We also did some of that this year, so you shouldn't have to reach all the way back to last year to remember it. Other examples: d equals negative 9c minus 1, y equals 2 bracket x minus 3 plus 6, y equals 2x. All of those are linear relations. And examples of quadratic: y equals x squared, y equals negative x squared plus 2, m equals 0.2n squared minus 3n, y equals 4x squared plus 2x minus 1. All of those are quadratic. What do you notice? Hopefully you've noticed that the equations of quadratic relations have a term with an exponent of, that's right, you got it, 2. Okay, so also, just like linear relations, quadratic relations can be written using letters other than x and y. So you can see that in this example here. So the definition of a quadratic relation has an equation that can be written in the form y equals ax squared plus bx plus c, where a, b, and c are constants and a cannot be equal to 0. And note, that means the highest exponent, as we said before, is 2. In the definition it says a cannot equal 0, and why not? What would happen if a equals 0? Well, let's see what would happen by substituting in for a 0 and see what we end up getting. If I do 0 times x squared, I end up getting 0, and so I wouldn't have to write anything there, and I would get y equals bx plus c. Does that look familiar at all? It should. It really looks like y equals mx plus b. All that's different is the variables. And as we said here, we could write it with different variables. This is now a first degree equation. There's no exponent of 2. Therefore, this is linear. And that is why a cannot be equal to 0. Because if a is equal to 0, you will no longer have a quadratic relation. You will have a linear relation. So we can put, you would get a linear relation whose graph is a line. For all quadratic relations, when a is positive, the parabola will open up. So that means it will look like that, up. And when the a is negative, the parabola will open down, right? And I'll put those here and here. And what a are we referring to? This a right here. And we saw that in the last video. We were working with equations like this one. And we had another one like this. Okay, and then when it was y equals x squared, a was positive 1. Therefore, the parabola opened up. When we had y equals negative x squared plus 1, the a was negative. It's negative 1, and so it opened down. Okay, and this is a little clue you can use here. P at the end of up is for positive, and at the end of down is for negative. What happens in the special situation where b is equal to 0? And actually, we just worked with that right here. So y equals ax squared plus c. The graph is a parabola with the vertex of 0, c. And so if you look at our example right here, the vertex would be 0, 1, because C is 1. And the same thing with the other equation. So 0, C. And then if C is 0, then the vertex is 0, 0, and the equation looks like y equals ax squared. So, I mean, this is in addition if C is also 0. So then if we had like this, for example, or if we had like this, for example. Okay, in that case, the vertex is always going to be 0, 0. So now I'm going to walk you through how to complete this chart that you can see here. In order to do this, first thing I'm going to do is I'm going to determine whether or not the equation is linear, quadratic, or neither. If the equation is linear, it'll have the highest exponent of 1. If it is quadratic, it will have a highest exponent of 2. If the highest exponent is something other than 1 or 2, then it is neither. I will then list the highest exponent in this column here. I will then write the vertex. If the equation is not linear, then, or sorry, not quadratic, then there will be no vertex, so I'll write not applicable. If it is quadratic, but I have not learned yet how to determine the vertex, that is, it's in a form you don't quite recognize, then you can put CD. And then for the last column, we'll determine if it is a parabola, whether or not it opens up or down. So let's just jump right into it. If I do y equals 4x plus 1 first, is it linear, quadratic, or neither? It's linear, so I can write here linear. And then what's the highest exponent? Well, it's 1, right? We're going to have an imaginary 1 there. It has no vertex, so I can write not applicable. And the parabola, it's not a parabola, so it doesn't open up or down. Y equals 3x squared. That is a quadratic equation. How did I know that? I knew that because I had a highest exponent of 2. What is the vertex? Look, if the equation is in the form y equals ax squared, that means the vertex is always 0, 0. You saw that right here. And then does the parabola open up or down? Well, the value of a is positive, and that means that it opens up. So you can write up, and it looks like that. Okay. All right, then what about y equals negative 9x to the power 3 plus 2x minus 4? Is that linear, quadratic, or neither? That's right, it's neither. And the highest exponent is 3. Remember, linear is 1, quadratic is 2. Anything else is neither. It has no vertex, and so I can write not applicable. It does not open up or down because it's not quadratic. What about d? D equals to negative 8g squared plus 12g. Is this linear, quadratic, or neither? That's right, it is quadratic because it has a highest exponent of 2. The vertex is, in this case, not something you've learned how to solve yet. You've learned how to find a vertex if b is equal to 0, or if b and c are equal to 0, but not if the b or c are not 0. Okay, so in this case we'll put CD because we can't determine yet. Can we figure out if it goes up or down? Well, a is negative, therefore it goes down. All right, and so I'm going to leave it to you to complete the rest of this handout as well as the other handout that goes along with this assignment. I will also post an answer key once you've submitted your work, everybody submitted their work, I'll post an answer key so you'll be able to check your work and make sure that you've done it correctly. Good luck.